Alright, good day guys, how are you all doing? We're talking about chemical reaction. And the aspect of chemical reaction we'll be dealing with is some little categories though. People has been finding it so hard to understand what they call chemical reaction. And it's kind of a little bit simple. So I'll start from the little aspect. And I want you guys to know something. Just note it at the back of your mind that when it comes to chemical reaction, we have the first process. And the first process is called the addition reaction in terms of type of chemical reaction. So without no wasting time, talk about types of chemical reaction. And the first one we have the addition reaction. Now you see this addition reaction, it actually tells us that when you have two elements or you have a compound or mainly a molecule, are you with me? They will have to form a new single compound. That's mainly a molecule. You get what I'm saying? So whenever you talk about addition reaction typically deals with a molecule or a compound. Or you talking about two elements. But there's now one thing you guys have to note. You see, whenever it calls any diatomic element, it is always in its state of gas. So when I say that, well, we all know that hydrogen, right, plus oxygen gives us your water, right? But how does that happen and how does that move come to play? I think that whenever it is a diatomic molecule, as you can see, it will not take ordinary H, it will take H2. Do not forget guys, H2, either they are being given off or they react. Any diatomic molecule is always in a state of gas. So you have H2, then O2 plus O2. And this instruction tells that it gives us water. You want that water is H2O, right? So this is mainly the instruction being given. So you have to follow instruction first. Then after following instruction, you now shuffle it back by balancing it yourself. And if you can look at now, this is two atoms of hydrogen here. I have two atoms of hydrogen here. But I could see that I have two atoms of oxygen here. I only have what? A single atom of oxygen here. Are you with me? Which says that I had to add two here. When I add two to oxygen molecule here, I have two here also. Are you get what I'm saying? So adding two to oxygen molecule there, I have four oxygen molecule, and still here I have two oxygen molecule and four hydrogen atom, which is here to what, to be balanced. Now when I add 4 here, 4 times 2 gives me 8, right? I have 8 hydrogen molecules here, but I have 4 here, which means I can easily add 4 also to here. Then 4 times 2, 8, 4 oxygen, 2 times 2, 4 oxygen, 4 times 2, 8. This is balanced already. Are you get what I'm saying? So let's assume we have I told you whenever you have hydrogen you have a gas. Let's say you have hydrogen plus chlorine gas. Now you all know this is hydrogen and chlorine gives us what? Your HCl, but this is not what? This is not balanced. How? You add your two what? Your two here. This is a addition reaction, a normal clear one whereby a particular molecule combine together to form a compound. This is a simple them. Are you with me? So please do not joke with all these things, they are very important. The second one we have what we call thermal decomposition. We have thermal decomposition reaction, and this thermal decomposition reaction is just like a reversible dem of addition reaction. Are you get what I'm saying? Now you see this one now, I want to also advise you guys something, and which I have told you guys already, which is not to be something new to you. This one now decomposes. This one decomposition, it decompose. Are you get what I'm saying? And when it decomposes, it gives us a suitable two products, at least two products. Are you get what I'm saying, guys? Now in these two products, if you are giving off any diatomic molecule, which I told you guys already, your hydrogen gas, oxygen gas, chlorine gas, and the rest like that, any of these things you are giving off would always come in terms of gas. Do not forget. So let's assume, so the composition means when you split, and this one means when you add two molecules together and gives us a product, a compound. And this one, when you now split that compound to give you at least a two, a two element, or you say a product, let's just put it that way. Now let's assume it gives us a product. Let's assume we have so the reaction for this, do not forget, this is A plus B. So A plus B will give you a totally new thing. As you can see, two hydrogen, different thing gives us what? Water. Same thing here also. So this one now is now the breaking down of C to give us two different things also, which is like what? A plus B. Are you get what I'm saying now, guys? So let's assume you have example 1. Let's say we have mercury 2 oxide. Mercury 2 oxide. When let's say it is heated, are you with me? And then it gives us mercury, ordinary mercury, and what? Oxygen gas. Now there's also one thing about unique thermal decomposition, is that one of the products must always be a gas. So even though they didn't write this here, you should know that what the oxygen that is going to be given off will have to be in terms of gas. So our mercury, which is mercury 2, as you can see, plus what? Plus our oxide. You have your O2 negative, and I'm trying to bring out the mercury whole thing. Then you have what? HgO. Again, that's your mercury 2 oxide. Mercury 2, then oxygen 2 negative. So you have HgO. Do not forget. So that means that mercury 2 oxide, which is HgO. Mercury 2 oxide, which is HgO, plus decomposes rather. Decomposes. What's wrong with this pen? Hey. So your mercury 2 oxide, it tells us that what decomposes into what? Into your normal mercury and what? Oxygen gas. So you can see that it is ordinary O that is there, but it's laterally what? Changes to what? Oxygen gas. So simply because I can't just give us ordinary oxygen, and the instruction is also there. So don't forget, it's very important. It could help you much more when you're dealing with any other chemical reaction. So, and is this balance? This is not yet what? This is not yet balanced. How do we balance it? We can add 2 to here, 2, then we also what? Add 2 to here. Are you getting what I'm saying? Now the next one we're talking about, it is one of the major important thing, which is called displacement, or we call it replacement. Replacement of chemical reaction. Are you with me? So do not forget, like I said, this is one of the most important one, and this is what give some students tough time. This is the third category. The first category, let me just put that way, that gives students tough time. Like, what is this? What's that? Yes. Now you see this category. This with who get power pass. That is who has this higher power in terms of positivity also, and even negativity. Are you get what I'm saying? So there are positivity and also what? Negativity. Now, displacement reaction is when, let's say, particular element A. Are you get what I'm saying? A particular element A use power to take what? To take the chance, or use power to replace, are you get what I'm saying, another element. Let's assume that we have two family now, a husband and a wife. Then we have a rich man that has money now. Then he use money to what? To collect this one wife. That is how they actually look like. Are you get what I'm saying? So, and mainly when you talk about displacement reaction, before you can understand it, you have to understand the arrangement of metals. And it talks about metals and non-metal. That is, let's just say, classify them as metals and halogen. It talks about metals and halogens. It talks about metal and what? And halogens. Are you get what I'm saying? So that is how they react with themselves. One is higher than the other. So that one that is higher will displace the other one. Are you get what I'm saying? So it will displace the other one. Now you see that movement that it does. That means when they displace the other one is higher, one is lower. That ranking is what we call activity series. It's called activity series. You know, when you talk about which one is higher, like this one has money higher than this husband, so he had to what? He had to throw away the husband. If he throw the husband away, he will what? He will inherit the wife. that's that's the work he does. You know, he's a crazy human being. Let's put it that way. So what do we talk about activity series? You see, it is actually how elements react. I get what I'm saying, to either, you know, just like we do now, displace the idiot husband and what? Acquire the what? Achieve the wife. Are you with me? So it is actually also used to predict at times. You know, most cases, if you don't even know, but just like this one reacts with this one, you don't even know how to react it. You don't even know if it's actually a reaction that could work. So it actually helps to also understand that okay, this reaction could work, this reaction can't. Are you with me? So most especially when you have a metal and an aqueous solution, are you get what I'm saying? Like some solution of salts in another metal too. It helps to understand if they would actually give you this or if they would not what work. And let's talk about activity series in metal first. In metals. And for metals, I want you guys to know something which is Pascal Pascal Mazi TLH cool MSG. So this is actually one crazy thing that is being developed though, which you might not really understand. So P takes for potassium, S for sodium, C A altogether, C in capital A. This is for calcium. You have M for magnesium, A for aluminium, Z for zinc, I for iron, T for tin, L for lead, H for hydrogen, C U for copper, and M for mercury, your S for silver, and your G for what? For gold. Are you get what I'm saying? So this is how they react in terms of metal activity. So you have potassium, you have your sodium. So this is how they are ranked. Potassium is greater than sodium. Potassium is greater than all of them. You have your calcium. We have magnesium. So these are greater than magnesium. You have your zinc. Okay, we have aluminium. You have your zinc. You have your iron. You have your tin. You have your lead. You have your hydrogen. Are you with me? Hydrogen. You have your copper. You have your mercury. You have your silver, and we have our gold. So these terms now, that means that if potassium should react with maybe sodium and one family, it will throw sodium away. That's what? Sodium is a useless human being. Are you getting what I'm saying? Telling that who are you, sodium? Let me know. Are you choosing? So you have to also understand something people don't understand is that some compound they do have SS. You get what I'm saying? That's why at times you see they have SS, they will add 2 to their front. That 2 is actually reasonable. And how do they do that? Before we move on, we have what they call radicals. We have NO3 negative radicals. You have CO3 2 negative. You have OH. These ones are normal OH negative. You have your HCO3 negative, and also we have SO4 2 negative. These are radicals. Now look at how people do make some mistakes. Let's assume that we want to, let's say iron plus AgNO3 combines together. You get what I'm saying? You know, before I move on, let me give you guys the how it displaces. Are you with me? So let's say that you have only a metal. Now this is how it talks. It says that a metal can remove a lower metal from another solution of a particular compound. So let's say that this is a metal A, then it reacts with another metal in a solution. it will give it will, if this metal is greater than this, it will throw this B out like I told you. So you have AC plus what? Plus B. So this is a form. So if you look at Fe and AgNO3 now, automatically this is where people make mistakes. We all know that this is Fe, right? And you have AgNO3. This should just give us easily as Ag plus you say FeNO3, but that is actually wrong. Are you with me? That is actually wrong. Simply because Fe plus the radical NO3 negative, Fe 2 positive. Are you get what I'm saying? So since it's 2 positive, you know your chemical reaction now. This one will come down here. This one will come down here. So this as a radical, they will be in brackets and they will take the 2 by neutralizing their sign. So from there, you have to know that this, let me write it here back. Fe plus AgNO3 won't just give you ordinary FeNO3 to be Fe into brackets NO3 then your 2 plus what? Ag, and that tends that changes, it has changes the balance of the chemical reaction. Are you get what I'm saying? So which it needs 2 here, it needs 2 here, and also it needs what? 2 here. So that is how they do form them. Are you get what I'm saying? That is how they do form them. That is how they are formed. That is how they have been formed. Let me see, this is not clear anymore. Oh, let's see. So that is how they are formed from that process. So let's look at another one. Let's assume you have, yes, another mistake people do make again. Let's say you have Ca. This is common. People do make a lot of mistake here. Plus H2O. Now I told you guys something. You know, this automatically calcium is greater than, this is calcium. Look at oxygen. So it is far greater. You know you ought to put Ca, right? Ca, then you have because we only have hydrogen to move away. So if you like, this is hydrogen H2. Then if you like, this is CaO. Then I'll have H2. This is totally wrong, my guy. Are you get what I'm saying? Because the water that is being given here is it's made up of, if you guys could remember from acid, a hydrogen ion plus what? A particular hydroxide ion. Are you get what I'm saying? So combining to give you water. And also again, also nevertheless, I told you guys a particular thing, that even your hydrogen itself, it will give off gas, right? But this can't be a well organized chemical reaction for it. Why do I say that? You have to confirm. You have to what? You have to confirm. Now I know that when hydrogen is being removed, what I have left here is not oxygen, is an hydroxyl. Are you get what I'm saying? So then I now check Ca, then OH. This is negative, I gave you guys here 2 positive. Then what happens next after this? The rest becomes what? An E3. Why? 2 comes here, 1 comes here by neutralizing their sign. So therefore Ca plus H2O gives me Ca, then OH 2 plus what? Your hydrogen gas. Naturally it will give us what? An hydrogen gas. You know that already, right? So that will be an hydrogen gas. So let's look at, is the equation actually balanced? No. So just like I said, this is already balanced. You have 2 hydrogen here, 2 hydrogen here, making 4. You have 4 hydrogen here, you have a 2 oxygen here, you have a 2 oxygen here, calcium. So the last one we're talking about is activity series in halogen. Are you with me? So in activity series in halogen, people do make a simple slight mistake also, and mainly we have the halogens. You have your fluorine gas, and you know they are also diatomic, greater than chlorine gas, and also greater than bromine, and also greater than iodine. Are you with me? So in this case we have it's called first. Oh, this pen is something also. You have first, this is called class bro Hue. So we have first class brohio. So fluorine as a gas can displace all of them here. I get what I'm saying. So you know it can throw them away, just like what we have been explaining right from onset. So let's assume you have a particular, I want to try to break something that people do make mistake of this thing. Now let's assume you have a particular gas like this, F2, I will mean that's fluorine gas plus um, KCl. Now some people might be like, what was this arrow I actually put here? This arrow, whenever a gas is being given off as a product, the arrow can be put there as upward. Whenever the product being given off is a solid, I get what I'm saying, the arrow can be put downward. So just that's just the function of the arrow. Now if you have KCl, now guys, this thing is very easier. We know automatically that fluorine would displace chlorine, yes, but people do get confused that since it is F2, won't it be normal KF2? No, this is wrong, because this fluorine here now, it wants to join with what do they call it, potassium. Are you with me? And throwing chlorine away. Now if I'm to throw chlorine away, I know I could have only ordinary chlorine. Don't worry, I'm coming to that. Then when I want to move on to now, you have to ignore this. And whenever I'm to combine, I have negative one, I have a positive one. So they combine normally as what? As KF, metal before non-metal. You guys know that. Then you now have to check it out now, because it has undergone a chemical reaction. We know that a product being given off cannot give us a metal. And chlorine, I told you guys that whenever any diatomic gas is being given off, it has to be in the state of its gas. So therefore Cl would be Cl2 as a gas. And looking at this now, are they balanced? No, you have 2 fluorine, so you add 2 here, which has also changed the what? The equation. So you have 2KFC and Cl2. So you have 2 chlorine, you have 2 chlorine, you have 2 potassium, and you have 2 fluorine. So therefore it gives rise to adding what? An extra 2 to here. So 2 potassium, 2 chlorine, 2 chlorine, 2 potassium, and 2 fluorine. So this is how they have been balanced, you know, when it's what actually displaces chlorine. So let's look at another one. Let's assume you have so you remember first class bro you. With that you could easily help yourself out. And from there we have what we call let's look at that example. Let's say you have something like chlorine gas. Let's use chlorine again. Plus let's say you have potassium bromide. That's KBr. Now just like what we have done, the same thing. Copper, potassium and chlorine. You have KCl. It's still the same thing. That you put Br first or this one, still the same thing, doesn't change. So you have KCl plus what? Br. Since Br is a diatomic gas, you'll be having Br what? 2. Then balancing them up, you have what? 2 KCl, and you should have 2 KBr also here. So this is the balance them of. We've talked about 3 chemical reaction. Now next class we move on from the to the 4th to the 5th chemical reaction and so on. So I hope this is helpful and useful to you. So you can also try many more as much as possible. So I didn't give them their values this, so make sure just know that this is the gases and aqueous solution name and the rest like that. My name is Crypto. Please subscribe to our channel. Thank you.